In this video, we're going to look at alcohols. The functional group of alcohols is the hydroxyl group. The hydroxyl group is known as the OH group, okay, so oxygen bonded to hydrogen. If the alcohol is the highest priority, we use the suffix OL and number the location of the hydroxyl group. If the alcohol is not the highest priority, we use the branch name hydroxy and number the location of the branch. When we look at this following molecule right here, we can see that the OH group is the only branch on this molecule. That definitely means that this is an alcohol, and the alcohol has the highest priority, so we number it with the lowest possible number, 1, 2, 3, 4. This is going to simply be 2-butanol. We look at this molecule right here. As you can see, I have a branch, I have a CH3 branch, and I also have an alcohol. So let's take a look at where alcohols rank on the priority chart in comparison to alkyl groups. Hopefully you can see here that alcohols are a fair bit high up, and they are certainly higher than alkyl groups, so we give the alcohol the priority, and we classify this molecule as an alcohol. So I number it from the right, 1, 2, 3, 4, and then I say 3-methyl, 1-butanol. Looking at this molecule right here, I can see that there's only a hydroxyl group on here, so that makes this whole molecule an alcohol. Let's number it from the right, 1, 2, 3, 4, 5, 6, 7, 8. Notice these aren't methyl groups or methyl branches, they're part of the longest chain, so you got to be careful there not to think of them as branches. They're part of the longest chain. So this is actually 2-octanol. Okay, finally we take a look over here. This right here, we can see the C double bond O right at the end, okay? This makes, because it is C double bond O on the first carbon, that makes this an aldehyde. And because this is an aldehyde, the OH group we treat as a branch. So that's this circumstance right here. The alcohol is not the highest priority. Aldehydes are higher priority than alcohols, so then this would simply be 3-hydroxybutanol. Alcohols can have 3 classifications based on the location of the functional group. Okay, so if I essentially have the OH sticking off the end of a molecule, so for example, I've got an alkyl group, then I have CH2, and then I've got my OH, that's called a primary alcohol, and that's because the OH is at the end. So we'll say OH at end, okay? You can also have a secondary alcohol where the OH is somewhere in the middle of the molecule, so we have R, CH, R prime, so alkyl groups on either side. And then up here we have the OH right there, and then we have OH in middle. Okay, a tertiary alcohol is one that where the carbon is here, there's an alkyl group here, an alkyl group here, and an alkyl group here. And then we have the OH group right here, and we say OH surrounded. As you can see by the note, primary alcohols are the most reactive since OH is accessible during collisions, and tertiary alcohols are the least reactive since the OH is surrounded by all these carbons and alkyl groups. You can also have a polyalcohol like glycerol, and a polyalcohol has multiple OH groups. We can see right here, this is called 1,2,3 propane triol or propane 1,2,3 triol, and that's because there are three alcohol groups or hydroxyl groups attached to each of the 3 carbons. The boiling points and melting points tend to be higher than other similarly sized molecules as a result of hydrogen bonding that occurs with the OH group there. If the alcohol has a large R or alkyl group, so if there's quite a lot of carbons in the alcohol, then the molecule is more likely to be nonpolar. However, if the alkyl group is small, like say it's a methyl or an ethyl, okay, and potentially there's a lot of hydroxyl groups, then the molecule is more likely to be polar. Okay. We're going to look at what are called preparation reactions for alcohols, and that means that alcohols are present as products. Okay, so the first preparation reaction that we have, how we make an alcohol, is the hydration of an alkene or an alkyne. So we'll take propene right here, H2C, double bond CH3. We'll react it with water in the presence of H2SO4. Okay. Again, you will recall Markovnikov's rule, which states that the carbon with the more hydrogens gets the other hydrogen, and the other group goes on to the other carbon. So this is going to be H2C. Note that I'm going down to a single bond, so then CH3. Okay, so the hydrogen goes on the first carbon right here, and then the OH goes on the second carbon. And then we're going to write the names in. Propene, water, and 2-propanol. Alcohols are actually also produced from the fermentation of sugars. So we have C6H12O6, okay, and then from there we can go to CO2, and we can get ethanol from that as well. H3C, CH2, and we have my OH here. I'm gonna fix that H because it's bothering me. And then I'm going to write the names, and I'm going to balance that reaction. Okay, so I have glucose, 2 carbon dioxides, and 2 ethanols. Okay, the following reactions have alcohols as reactants. Okay, so one of the ones that we have seen before is the combustion of ethanol. Okay, so I'll have C2H5OH plus O2 goes to form CO2 plus 3H2O. I'm not going to worry about writing names underneath this one. These combustion reactions we've been seeing for a while, so you know what everything is here. Now, elimination or dehydration is one that you may not have seen before, and that is we're going to take an alcohol and we're going to form an alkene. So 2-propanol in the presence of H2SO4. So let me draw my 2-propanol molecule. Okay, and then I'm going to put that in the presence of H2SO4. Let's not forget the hydroxyl functional group right there. Okay, and then the OH is going to come off. In addition to one of the OHs coming off, one of these H's is going to come off as well. So I'll say H2C, double bond. Okay, actually, why don't we make that double bond red, because that's what's forming in this reaction here. Okay, and then I'm going to have CH, so one of the H's came off here, the OH came here, and then I have CH3, and you can think about it, if the OH came off and an H came off, well, you may have guessed it, water forms. Okay, we're going to write the names. 2-propanol, propene, and water. Okay, the final reaction that we're going to look at today is a substitution reaction. You'll note that these reactions right here, controlled oxidation, condensation, condensation, we're going to study these later in more detail. So we're not going to put examples here. This will be our final one that we're doing for this lesson. Okay, substitution of an alcohol with a hydrogen halide. So I'm going to take 1-propanol right here. So I'll do H3, oops, let me just get rid of this. 1 second, please. Okay, perfect. H3C, CH2, CH2, and I'm going to have my OH here, all right? And it's going to react with hydrogen chloride, HCl, okay? And then I'm going to make H3C, CH2, CH2, and it's a substitution reaction, so that means something's going on, something is coming off, okay? So the Cl is going to go onto the molecule right here. Okay, and then coming off the molecule, well, you guessed it, it's the OH, and then the H is still left over, so we have HOH, which is water. Okay, so we'll write the names. 1-propanol, hydrogen chloride, 1-chloropropane, and water. You can also take alcohols, involve them in controlled oxidations to form aldehydes and ketones. You can condense alcohols to form ethers, and you can condense an alcohol and a carboxylic acid to form an ester. Thanks for watching.